Hello friends, today we will do a problem from Stiver's list, DP on subsequences. The problem is subset sum equal to target. So let's open the gigs for gigs problem statement. Yeah, so the problem is subset sum problem. So in this problem, given an array of non-negative integers and a value sum, we have to determine if there is a sum, if there is a subset of the given set with sum equal to the given sum. So in this problem, we have given an array and we have given sum. So we have to return that is any subset in this array which sum is equal to this sum. If yes, then we have to return true, otherwise we have to return false. So yeah, so let's discuss this problem. Let's take this problem. Yeah, okay. Yeah, so we have given array 3, 34, 4, 12, 5 and 2. So we have to find a subset which sum is equal to the given sum, which is 9. So how we can do using a dynamic programming? So let's try to understand how we can do using recursive method. Then we will optimize that to dynamic programming. So uh, we are doing here all the ways. So let's see. Let's see. In my subset, 3 is in my subset. So 3, and we move to the next index and take this 34 to my subset. 34. Is it possible to take 34 in my subset? No, because when we add 3 to 34, it becomes 37, which is greater than the sum. So we cannot include 34 in our subset. So exclude this, then move to the next index and add this 4 to our subset. So plus 4. So can we add 4 to our subset? Yes, because then sum equals to 7, which is less than our current sum, which is less than sum. So our current sum is less than sum, so which is 7 now. Then again we have to move next and add 12. Can we add 12 to our subset? No, because then it becomes uh, 19, 19, which is greater than the sum, which is 9. So we cannot include 12. We cannot include we cannot include 12 here. Can we include 5? When then we have to move to the next index, and can we include 5 here? No, because when we add 5, it becomes 12, 12, which is greater than the given sum, which is 9. So we cannot include 5 as well. Can we include 2 here? So we will move to the next index, and can we add 2 here? Yes, we can add 2. then it becomes 7 3 7 7 and 9, which is equals to 9. Yeah, the now sum becomes 9, which is equal to the current sum equal to the given sum. Though, so yeah, it is possible uh, to take a subset which sum is given sum. So there is a lot of ways to do this. So let's see, 3 34 4 12 5 2. So how we can approach this problem? So in our subset, so let's see our subset is S. In our subset, what we are saying is uh, we can either include 3 or not include 3. Either we can include or exclude. If we include if we include 3, then sum becomes 3, in our subset becomes 3. If we exclude 3, then our subset is still 0 because there is no element. Then we move to the next index. We will move to the next index and check either we can include 34 in our subset or not, or either if we include in our subset, if we include 34 in our subset, then there is two possibility, because we have two sets, so either we include 34 in our subset, or either if we exclude 34, then this becomes 3 and it still becomes 0. So for every element we have two possibility, either we include that element or we exclude that element. So in this problem, what we do, we create a function in which we call that function and move to the next index, and one time we include the current element to our subset, and second time we exclude that element from our subset. So from doing this, uh, we cover all the ways, and using optimization, we will do that problem in order of n into sum time complexity. So let's see here. So how we are doing, how we will approach this problem. So yeah, so in our function we have array. uh, we will assume an index, and which is the current index, and we will assume a current sum of a subset. Let's erase this. Yeah, so how we'll do this, so uh, using recursion, we will call function of idx plus 1, idx plus 1. One time we will include the current element, which is array of index, array of idx plus current sum, array of index plus current sum, and one time we will exclude So idx plus 1, idx plus 1 array current sum. So just 1 second. So here we are not adding array of idx. Here we are not adding array of idx uh, because we are excluding the current element, or here we are including the current element, and seeing that if it is possible to uh, make a subset using this element such that sum of that subset will be uh, the given sum. So let's see the code how I did. So here this function is given to us. So here created a new function in which I passed array and sum, and this is the current index and this is the current sum. So index and current sum which is initialized, and this is the DP, 2D DP in which we'll store the sum and index. So we have to do this problem in sum in order of n. So here I stored -1 and pass this dp to function. And here I initialize a carry, which is globally I initialize this value to false. And here in this function, if it is possible to subset sum is equal to sum, then we will storing the carry value to true, and we are returning the carry here. So let's see this function. So if current sum, which is the subset sum, equal to sum, then we are storing carry equal to true. And if index is greater than equal to array of size, which is auto bound, then or otherwise if we are pre-calculated the value of carry, then we are returning here. We are not further doing this call. So, and again, if a dp of current sum and idx equal to not -1, that is, if we pre-visited this current sum and index, then we don't have to do again. So we are returning here, and if current sum is greater than sum, so again we have to return, as we discussed here. As we discussed here, if 34 will be added to 3, then we have to exclude that 34, so we have to return. So yeah, and this is the function. First time we are include the current element to our subset, and second time we are excluding the current element, and yeah, this will calculate the value of carry, then we have to return this carry. So let's run this. Yeah, accepted. So the time complexity is order of sum into n, and the space complexity is also sum into n. That's it. Thank you.